In this video, we're going to be expanding upon our knowledge of distributive property and looking at combining distributive property with what we know about like terms and polynomials using a couple examples here. If we take a look at example 4a, we can see that there are two situations where we would use distributive property. So remember, whenever we have any coefficient or variable that is next to a bracket like this, there's an invisible multiplication sign. And remember, whenever we are multiplying a coefficient or variable by anything in brackets, we're distributing it to every term within the brackets like this. So the first example of distributive property that we're going to use is -4 multiplied by x and by +3. So let's go ahead and do that now. So -4 times x would be -4x, and -4 times +3, because the signs are opposite, this would result in a negative number, and 4 times 3 would be equal to 12. For the next example, or rather the next half of this question, again, there's an invisible negative sign next to the 2, because the 2 is immediately next to this bracket here, and we're multiplying 2 both by 3x and by 5. So let's go ahead and do that. +2 times 3x would be +6x, and then 2 times 5 would be +10, again, since both numbers are positive numbers. Now, at this point, we can recognize that we have two sets of like terms, that being -4x and +6x would be like terms because, again, same variable and same exponent, whereas -12 and +10 would be like terms because these are the constants in our polynomial. So if we go ahead and simplify this, -4x plus 6x means that we would have +2x left over, because +6 minus 4 would be +2, and for our constants, -12 plus 10 would be -2, because -12 plus 10 means that we have -2 left over. So this would be our simplified polynomial, in this case a binomial, once distributive property is applied. Now, if we take a look at the example below, or actually let's take a look at example E, because we would result in the same phenomenon here. What we want to see is how many like terms we will end up with if one of the coefficients, in quote, that we're multiplying, that we're distributing, actually contains a variable here. So the first distributive property we're going to use is 3x times x and 3x times -2. So if we go ahead and do that, 3x times x, there is no coefficient in front of the x in the brackets, so effectively we're doing 3 times 1, and then we recognize x times x, we're multiplying x by itself twice, and so this would become x squared. Then 3x times -2. -2 has no x within it at all, so all that we're doing is -2 times 3, which would be -6, and then the x term remains like so. Next, we can apply distributive property to the second half of our original polynomial, multiplying 4 both by x and by +2. So +4 times x would be +4x, and then +4 times 2 would be +8, and this is our polynomial once both of the situations involving distributive property have been expanded. Now, we recognize in this situation that we only have two like terms here, -6x and +4x, because we only have one constant, and because we don't have a term that has x squared other than the first term that we see here. So our simplification will actually be fairly straightforward. 3x squared carries down because there is no other x squared term. Then -6x plus 4x would be negative 2x when it's simplified, because negative 6 plus 4 is negative 2, and then we would leave the constant positive 8 as itself, because there is no constant term within the polynomial that we created here. So in this situation, our simplified term, once all like terms have been collected, is actually a trinomial here, because once again, x squared and x are different terms because the variable is different between the two. So this concludes our video on combining distributive property with our knowledge of like terms. In order to test your knowledge, try the practice examples below that first involve expanding polynomials using distributive property and then combining like terms in order to provide a final simplified polynomial, such as the two examples that we took a look at in this video.